Well, hello, everyone. Welcome to the Streaming Alchemy Show. I'm John Mahoney, and on this show, we're going to talk about NewTek's really groundbreaking protocol, NDI. But before we get to that, I want to remind everyone that we will be taking live video callers from the viewing audience. So if you have a question or want to share a thought or a comment, please just contact us at this link below, https call-in.tv/streaming alchemy. We'd love to have you on the show and we'd love to hear from you. Okay, so let's get started. Probably the first place to look, if we're talking about, let's put the slides up, is we're looking at NDI. So the first question is, what is NDI? And I think there's a really good definition I saw that I want to share. So first off, NDI is a protocol. It's a way that systems can talk with each other that allows systems, devices, and applications to connect and communicate over IP, sharing video, audio, and data. And there are three key things that we want to really focus on in the show today. The first is that this is more than just connecting a camera. It talks about devices, but it also talks about systems and applications. So we're really talking about the way video production is done today with computers, with software, as well as with traditional device gear like cameras and CG systems. The other piece is that it communicates over IP. And we'll come back to this, but that's a very, very key concept to keep in mind when we talk about NDI. And the other thing about it is that we're talking about video and audio, which traditional SDI does, but we're also talking about data. And data is, again, a key piece of modern productions where you have everything from control to metadata that needs to be moved around a studio. So if you think about IP video, the best way to think about it is to consider how you have things set up in your house or in your office. You have multiple devices that are all hooked up to a central switch, a common communications device, and they're all able to talk to each other. So if you want to print to a printer, both your devices are on the network, you can print. If you want to share photos from your iPhone to a file store that you have on the local area network, again, these types of connections are there and they're all dynamic. So one of the key things to consider when you think about IP video is that it really takes on the character of all the other IP connections that you're familiar with. This dynamic, real time, in the moment connectivity and sharing. So, what about SDI then? What is it that's limiting about where the traditional industry is right now, which is SDI? Well, SDI stands for Serial Device Interface, and uh, Serial Digital Interface. Excuse me. So it really is about the same basic types of information flow when it comes to audio and video. You have digital video, you have multi-channels of digital audio. They're going across a wire. But the couple of key differences come to what we talked about in that first definition of NDI. It's not IP based. So SDI connects one device to another device. It's a point to point protocol that moves in a single direction. So I feed from a camera to a switcher. Uh, it's not routable then. It is not something that would easily play in a dynamic environment where I want to take a single feed and move it to different locations and switch between them all using software. It really isn't designed for that type of environment. So let's just look at it in the context of controlling a PTZ camera. With SDI, you actually need three wires going to this camera. You'll need a control wire, so that will allow everything from the pan, tilt, and zoom, but also all the configuration details, anything you need to do to dial in iris or dial in color. All of those things are handled through one control line. The other is the SDI line itself, which carries the video and the audio. And The third is power for the device. So for this one camera, you need three distinct wires. But with NDI, you're down to one cable, one connection. Because NDI is built around common Ethernet-based protocols and technology, uh, you are able to power the camera using power over Ethernet. Very common, powered switches can power the cameras. You also have the audio and video sent over the one cable. But the other piece, and this is another one of the distinctions we talked about with NDI, is that we also have a data channel in NDI. So all the things that were coming over a separate line into the control points of the camera now are done using IP, over using data over IP to again do all those same types of settings. And while you may think it's not a big deal, for a single camera, when you start to think of it in the context of studio installs and setups, when you do things, especially on location, it becomes a bigger issue. So here is just a small studio setup, basically, four separate cameras, and they're going into a switcher and streaming out to an audience over the internet via a CDN. So in this diagram, you can see now that I have to worry about routing power and making sure that power doesn't interfere with the cabling that I need for control or the SDI for audio and video that's coming back to the switcher. So not only are there more cables involved, you also have to worry about sort of the physical layout of all these cables and how you want to route them to devices. But with NDI, they all become a single cable, a single data cable, less likely to interfere with anything else. And they all come back to the same core infrastructure that the rest of the studio is using to talk out to the audience and the internet. And that's an important consideration here. Everything that you see in this diagram, where we're looking at everything sort of from the bottom up, all of that is IP based. It's all IP based video streaming over the internet. So everything from the encoder, the switcher and encoder out is all based on IP protocols. And what we're doing here is simply bringing all those routable, configurable advantages we have in that part of our infrastructure into the actual studio space itself. And all of this now becomes IP based. So let's look a bit more in a bit more detail at some of the differences between SDI and NDI. And the first one, and this is really important because it's sort of a plus and a minus with NDI. SDI is uncompressed. So bit for bit, whatever starts at the wire ends up in the other end of the wire. NDI is compressed. But the compression used in NDI is typically what's called visually lossless compression, where unless you're actually sort of pixel peeping at different areas of an image you capture, you're not going to notice it as a normal user. The big advantage, though, to having that level of compression is that the data size is dramatically lower. So if I were to take a single SDI connection for a 4K camera, that connection would be 24 gigabits of data per second moving along that cable. The same 4K connection under NDI is 250 megabits. So very, very significant differences between the the data rate that's needed to sustain those video flows. And that's one of the big points of IP-based video and NDI. SDI being point to point can take that one wire and fill it up with huge amounts of data. It's talking just from one device to another. NDI, on the other hand, is available on a network. It can be picked up by multiple devices, routed in and out of systems on its way to actually making it to an audience. So having smaller data rates means you have many more options to route that data, and it becomes easier and less expensive to route. Very big selling points and a big part of the flexibility that NDI offers. So the other piece, and this is becoming more and more important today, SDI supports fixed resolution. So standard definition 4:3, 16 by 9 flavors of HP of HD resolution, so 720, 1080, and UHD and 4K and uh, actually even up to 8K video now is supported. But all of these are fixed layouts, fixed resolutions, fixed aspect ratios. NDI doesn't care about resolution or aspect ratio. And when you think about how video is being shared today, it's much more than what you see on the traditional screen. You have social media using square video and portrait video versus landscape video. You also have video being used in ways that are very different from traditional viewing venues. You would have concerts you go to where you can have the whole back wall of a concert arena be one big video wall and changing all the time. There's no fixed aspect ratio to that. You can have sides of buildings have video where it's all used for advertising. Uh, the traditional formats used in video are really being pushed aside for a far more flexible framework to display video content in. And I think NDI is ideally suited for that. The other thing which we talked about a bit was that SDI is single direction for audio and video. So if I want to connect one system to another over SDI, the video originates in one system, ends up in another. That's it. That's all that happens on that cable. You have that and you have the audio that's going through. If that other system wants to process that video and send it back, you need another SDI port, you need another cable, and that has to be routed back. NDI is by nature bidirectional. It's all sitting on a switch in an infrastructure where I can move data from a computer and data to a computer, from a device to a computer. All of those things are natively bidirectional, natively routable. So makes an NDI production environment far more flexible. And part of that routability is that in NDI, like I mentioned, sources are patched. You have to screw in a cable to one end, screw it into where you want it to go. NDI is discoverable. So if I have a system that is making 3 or 4 different video sources available, any other system on that network can now just say what video is available, see it in a drop down or some other way that the software wants to display it, and connect to that video directly. So very easy to advertise video that you want to share, very easy to subscribe to video that you want to take and process. So again, very much in keeping with a modern production workflow. And the last piece of this, which is really the core of modern production workflows, is that SDI was designed around a hardware base. You have specific boards or ports on devices that you plug the cables into. NDI is designed around software. It is from the ground up a software-based protocol. And this means that you can use it not just device to device, but you can use it also now computer to computer. I can use it from device to computer. And I don't need to buy additional hardware. There's no additional cards I need to take and ingest NDI video. Very powerful, very cost efficient, and very, very flexible. So when we think about NDI, people typically talk about it as just NDI, but there are actually 2 flavors of NDI. One of them is called NDI HX or NDI high efficiency. So high efficiency NDI is really just more highly compressed NDI than standard NDI. That's it. So the data rates are significantly reduced. And because of that, the quality is reduced somewhat as well. And there's more latency because the way the compression works, it needs to have more frames of video in place to then apply that compression. So you actually have multiple frames of video in latency when you use NDI HX. And with NDI, you typically have 1 or fewer frames of latency, which puts it on par with what you'd get with SDI video. The big difference, though, is in data rates. NDI HX uses significantly less data. For all the data rates in HD from 720 up through 1080/60, you are still below 15 megabits per second for what you need to transmit those video and audio signals. NDI, on the other hand, runs anywhere from 90 megabits to 125 megabits to transmit HD video. NDI-HX has no support for 4K, but NDI does, and that supports it at 200 megabit and 250 megabit for 30 frame 4K and 60 frame 4K, UHD 4K, not DCI 4K, just so I'm clear on that. So this gives you an idea of why people would want to use NDI-HX. But even with the significantly compressed data rates you have in it, the quality is still pretty good. The camera that I'm looking at right here is an NDI-HX camera. The camera that I have as our main camera over here, this is an NDI camera. So there's slightly shifted latencies, but nothing significant. And overall, the video quality for most video productions of NDI-HX will probably be fine. So one other thing to think about, because it's a key selling point of NDI, is that it runs on your traditional installed networks, 1 gigabit switches and traditional network wiring. I talk to a lot of people, and this can be very confusing to some of them. When you look at a 1 gigabit switch, what you're really talking about is the available bandwidth that I can send to and read from that switch with one single device. So if I have a camera, the most data that camera, or if it's a computer, the most data that computer can send to the switch is 1 gigabit, and the most data it can read from the switch is 1 gigabit. However, that has nothing to do with the total bandwidth that can be passing through this switch. So if you had multiple switchers on this switch, and you had cameras that were going to both of those, each one of those switchers could take up to 1 gigabit data streams from all those cameras that are available on the network, even though in terms of the total capacity of the switch, that would be far greater. So keep that in mind. You have more bandwidth in that switch than just the 1 gigabit. It's just 1 gigabit per port. The other thing is, and this is something you see all the time, some people look and say, why would you spend tons of money for expensive switches when I could buy, ones at Best Buy for $150, $200? And the reason is the innards of the switchers can be very different. And based on how heavily you will be loading them in a production, those higher end switches could pay off. The total bandwidth in a switch is based on something called a switching fabric. So that's the total bandwidth that's available within that switch. There's blocking switches and non-blocking. Blocking switches usually have less bandwidth than the total bandwidth of all the ports if every port was fully loaded. So non-blocking switches, that typically isn't an issue. The other thing to think about with higher end switches is that they will have higher packets per second that they can transmit. Again, the data that's coming across in IP video or any IP communication comes in fixed size packets. And as those packets move across the network, they're assembled at the other side. There's a limited number of switches of packets that can be sent in any given second, and that can impact the amount of bandwidth the overall switch has. And the other thing is, more expensive switches have much more sophisticated internal buffering and the way they block and time data. So again, you get a lot more value at the low end if your demands of the switch are going to be a lot lower. But if you are dealing with a sophisticated high bandwidth infrastructure, those higher end switches can make a difference. So one of the things I wanted to do for this show is I want to do a bit of a demo. So we've talked about NDI and sort of the nature of it in a production. So what I want to do is show you how you can take route NDI sources to an external system, do processing to it, and then feed it back into your switcher to display on air. So if you look at this diagram, what we're going to be doing for this demo is we're going to be taking and feeding the PowerPoint that you're seeing here. That's actually going out on the network via a free NewTek tool called NDI Scan Converter. So if you want to look at the free NewTek tools, please just check out newtek.com and look for free NDI tools. Uh, we're going to be taking that feed. We're going to be taking output from this camera right here, which is also, this is NDI HX coming out. We're going to be taking 4 outputs from our live to air system. Our live to air is the system we use to bring remote guests and live callers into the show. So that's going to be sending out 4 NDI feeds there. We're going to be taking and sending those to a computer that's running OBS. OBS is going to take and composite those feeds into one single NDI feed that will be sent out and go back to the TriCaster for display inside a virtual set. So one thing to keep in mind here, in addition to the way NDI is being routed, is that OBS is now running on a separate computer from the switcher. So it's another processing point in the studio infrastructure we have here. And the video we're sending out is non-traditionally sized video. So this is going to be video that is 3840 by 1080, so a double wide HD video. So let's actually switch over to the demo here. Okay, so what you're looking at here is a virtual set running inside our TriCaster. And in that virtual set are 3 inputs coming in. One of them is our host. Another one is a small monitor in the back, which in this case is showing the screen of our OBS system. So you'll be able to see what we're doing as we make changes. The large monitor on the left of the screen here is actually going to be showing the composited video that's coming back from OBS. So let's take and bring on 4 guest videos. So if we had a situation here where we wanted to have a panel discussion with 4 remote guests over live to air, we would be able to take those feeds, composite them for the wall. We've cropped them, if you notice, so those are all half-size windows. So the center half of those videos is all that's making it out there. And then we can display that out as a single feed that displays on the monitor here in the virtual set. So now if I wanted to go and join them, again, this is everything you're seeing happening on this monitor now is happening in OBS. This is just a fixed shot in the virtual set that we're using for this demo, but somebody now in OBS is controlling dynamically what gets displayed on the screen. So here we have 5 NDI streams, the 4 from live to air and the 1 from the camera here, going to OBS, composite, and coming back. And now, again, if I wanted to say, let's bring on the PowerPoint as well, and I want to have a discussion talking about the slides, I can go and you can change the slides here. I can talk to any of the guests. And again, all this is being done outside of the TriCaster in OBS and all using NDI point to point. So if you just make this full screen so people can see it a little clearer, this is the type of production opportunities NDI can bring to you. So when you look at these things now, you're no longer limited to these point-to-point connections. Here, I just take multiple sources, add them into OBS, feed out OBS to the network, and add that into the TriCaster. There's so many different ways this can be used, but this is just one approach to think about when you start to look at different ways you could add value to your productions. So, okay, let's jump back. So, one thing I wanted to touch on before we end the show is that there is another version of NDI that NewTek announced at this year's NAB show in Vegas this past April. And there are some significant changes being made to it. So one of them is that they're doing higher quality at lower bandwidth. And again, anything that reduces the size of the data that needs to be moved around, the more efficient the production becomes, the less strenuous it becomes on all the infrastructure in the studio. So that's a big plus. It's going to now have higher color accuracy, 16 bits per pixel in color accuracy. And when I mentioned before that video is no longer just confined to screens, where you start to have video over huge spaces, the sides of buildings, the back of stages, that higher resolution video quality. So stop some of the banding you can see if you have a smaller color space to work with. So again, something that's going to accelerate the types of use cases that NDI is perfect for. Uh, One of the other things which is going to be huge for many, many facilities is that once that NDI stream is on the network, you'll be able to record it across multiple machines and all in time sync. So if you want to do a live stream, but then take all the video sources that made up that live stream and use them in post production to create different flavors of the video, different things for social media, different things for marketing you may want to do, you can now not just have recordings, but you can lay those recordings out in a timeline and cut between them all in perfect sync. Very big deal. And sort of with all this, they're lowering the CPU load that NDI is going to require. So that's again going to make a very big difference in the starting point for people. If people can start to use NDI with lower end systems and integrate lower end systems into their production environments, it's just going to give more opportunities and more flexibility in the market for NDI. So again, I want to thank everybody for taking the time to join us on this show. Uh, this show's a little bit shorter than the one we had last week, so I know last week ran a little long, but I want to get something that still gave you enough of a look at NDI to feel comfortable sort of exploring it for yourself and looking at ways you can integrate with it. So for our next show, for next week, next Friday, same time, we're going to be looking at the Stream Deck XL. So Stream Deck has been making a line of LCD-based control surfaces for many years, and they've just released one that actually has a large number of buttons on it. Each of these buttons is programmable and can really help you streamline what you need to do for switching and managing a live production. So we're going to take an in-depth look at this next week, but until then, thank you very much, and I'll see you. Take care.